Okay, let's sum up a bit about these ideas of injectivity and surjectivity for a linear map. So we assume that we have a map F that belongs to the set of all linear maps that go from a vector space E to a vector space F. Okay, so let's start with injectivity. So what does it mean to prove that F is injective? It means that the definition, or more like the theorem 15 tells you that F is injective if and only if the kernel of F is reduced to the zero element. The kernel of F being the set of X that belong to E, such that F of X is equal to 0. That's the kernel of F. That's reduced to only the zero element. Okay? What can you do to prove this property? So that's exactly like the null space that you used to work with matrices. How do you do to prove this property? You assume you have X that belongs to the kernel of F, and then it's very direct. You show that F of X is equal to 0 implies that X is equal to 0. Okay, and if this is not true, then so that's the 0 of F. If this is not true, then you don't have an injective map. If this is true, you have an injective map. Okay, so that's for injectivity. Now, if you want to prove surjectivity, so what does it mean for a function to be surjective? F is surjective if and only if for all y that belong to the codomain, there exists some x that belong to the domain of f, such that f of x is equal to y. Okay, so either you can show it directly, or if f is a finite dimensional space, what can you do using what we just showed before, the theorems 18 and its corollary that F is surjective? Well, of course, if its image is equal to F, to add to its codomain, and in the case where F is finite dimensional, then it's surjective if the rank of F is equal to the dimension of F. So what should you do? You should look at the system that of the image of a basis of E. Okay, so that's the image of F. We already saw that, and the rank of F is going to be the dimension of this system. So do we have that the dimension of the spanning set is equal to the dimension of F? Okay, that's what you should show. How many linearly independent vectors do I have in that spanning set? Do I have enough independent vectors so that I can build the whole of F?